And so I would like to welcome our next two speakers, Nici Bergroth from Fortum and Helen Cook, our partner, to talk about the SMR licensing model for Estonia. I hope you are with us.
So before I go into my presentation, which is a brief introduction to the licensing study that we have done in cooperation with Fermi, I want to thank my co-authors, Pekka Nuutinen from Fortum and Helen Cook. So this is a brief introduction to the SMR licensing study that we have conducted, Fortum and Fermi together. And the content of my presentation, I will just give you a short introduction to the licensing study, just the purpose, the role and goals of the study, and then present the main results, the general licensing process and a possible licensing model. And in conjunction with the licensing model, we have also considered some possible examples for application of graded approach in the safety assessments. And also I will discuss briefly about the objectives and methods regarding the different safety assessments. And then I will wrap up with key findings and conclusions. So the main goals of the licensing study was to seek an efficient licensing model for obtaining a construction license for SMR in Estonia. And a legislative and regulatory blank canvas was taken as a starting point. And the study was aiming also for a 12-month regulatory body approval time. And it could be said that the study particularly considers Estonia as a newcomer nuclear country, but also that the model could be accepted more broadly. And the general idea that was utilized and built for what the study builds upon is that the licensee is ultimately responsible for safety, and also that the national regulator must have competence and resources to independently ensure the safety of the plant. However, in this study, the idea has been taken that to use to a maximum extent an existing safety assessment of a foreign regulator, so that the Estonian regulator would use the safety assessment from a foreign regulator that has licensed the SMR design in question. And that would mean that the project and the design would not be a first of a kind in Estonia. And what this would then mean, it would mean that the Estonian regulator would verify the foreign safety assessment and accept it to the extent possible, minimizing all design changes, and design changes would then be limited only to the site. And the same applies for the supplier organization and the supply chain. And for this, there would be no detraction from the independency and the sovereignty of decision-making of the national regulators. The focus is clearly on licensing from nuclear legislation and regulation point of view. The conventional permitting has not been in focus and has not been addressed, and that is something that needs to be further investigated also when it comes to licensing and permitting. The main focus is really on how to obtain a construction license in practice. We have utilized 3 licensing areas in the study, namely being the site, technology, and organization. And in the study, the focus is on the technology part, how to license the technology. We have emphasized intelligent customer and the role of the license applicant safety assessment in the study. And in general, the study was made to be technology neutral and universal so that it could be adapted into whatever the framework of the model to be utilized in. And the main results really is a general licensing process that is based on an overview of different licensing approaches and licensing phases in selected countries, and the feasibility of those have been discussed from the deployment point of view in Estonia. And in the study, we selected or addressed the countries US, Canada, UK, and Finland. And then the licensing model based based on a leveraging on an existing foreign safety assessment and the safety assessments of the license applicant, as well as the national regulator based on a graded approach. And we consider that the scope of the foreign safety assessment would be one dimension in the graded approach, and then the safety significance of the subjects for the safety assessment would be another one. We also briefly discuss an additional viewpoint, which would be a system engineering hierarchy. And but in this context, it has been just provided as an additional example, demonstrating that it can be done in different ways. And in connection with the safety assessments, when talking about grading, also the objectives and methods of the different grades and the safety assessments have been presented. So regarding the general licensing process, it is a discrete step licensing process consisting of 4 main phases, being the decision in principle, construction license, operating license, and decommissioning license. And I will focus on the 2 first steps, which are heading or targeting the construction license in more detail in this presentation. So the first step is a decision in principle, which would be a political decision regarding a particular nuclear facility project. So this is not the IAEA milestone 1 national position, which is assumed in this study to have been taken earlier. So the decision in principle would thus be granted during the IAEA milestone approach phase 2. At this stage, the focus on technology and site should be very limited and limited only to a preliminary safety review to ensure the availability of technology and also that there are some site alternatives available. And this is actually the approach would be closer to the original intention of the decision in principle as it has been in Finland. Also, at this stage, a strategic environment assessment is considered to be sufficient, and detailed environmental impact assessment could be conducted later. The decision in principle would be granted by the government, potentially ratified by the parliament if so wanted. And in parallel, and even before and also after the decision in principle, it's included a topical pre-approval process, which would include binding regulatory approvals, similar to the US NRC licensing topical reports process. And such binding pre-approvals would be provided to high-level safety issues, conceptual issues, which would be fundamental for the project and in order to reduce the licensing risks and increase the certainty for the project. The construction license would be a combined safety assessment of the site and technology, which would be carried out based on the site-specific design. And at this stage, also the detailed environmental impact assessment would be carried out. And benefits would be that it could be done only for the chosen technology as well as for the chosen site. And from the regulator point of view, of course, in addition to the technology, the supplier organizations, the supply chain, as well as the license applicants' resources and competence would need to be assessed. And the construction license would be granted by the regulator. And then this scheme provides an overview of the 2 first phases, the decision in principle and the construction license, from a little bit different angle and point of view than the previous pictures. But from this picture, I just want to highlight that in the upper left corner, where the foreign regulatory body as well as the vendor is present, that the safety assessment of the standard design or a reference plan, as well as a potential design certificate or a construction license, would be the basis for obtaining the construction license. And when it comes to obtaining the construction license in practice, I'm focusing in the next slides regarding the practical elements regarding the safety assessment of the license applicant and the regulatory body. And for the safety assessment, this slide shows or presents an example for an application of graded approach. divided into two different dimensions. That would be the safety significance of the items, as well as then the reference design and potential deviations from the reference design. And such deviations, they could be based on local requirements, lessons learned, or then the site and environmental conditions. And as mentioned earlier, in order to minimize the designs, really to limit them to site and environmental conditions, this colorful scheme could be transformed into a little bit more boring with just two colors, but really to focus on the site-independent design and the site-dependent design, and considering the safety significance of the items. And for the safety assessment, the objectives and methods, the high-level goal is, of course, both for the license applicant and the regulator to understand the safety performance and the safety features of the plant. In the previous picture, the four different grades of safety assessments, just to show a little bit some concreteness in the objectives and the methods, that the grade A would be concentrating on verifying detailed safety requirements, whereas B, C, and D grades would go from general safety requirements to high-level safety requirements, ending up in just verification of the safety principles in grade D, excuse me. And when it comes to the methods, grade A in this example would be a purely independent safety assessment with using own methods, own tools, own inputs. Whereas then in the grades B and D, the grading is regarding the methods, tools, and input data and results, and also from the regulator point of view, focus on the license applicants and the designers' processes, how this license applicant is doing their safety assessment. And based on this, then the regulator could also give some more credit on the work done by the license applicant. And then the key findings and conclusions. Really, an international and European design certification, that would be an optimal way to support an Estonian licensing process and a model. However, this is something that cannot be expected in the near future, or at least not on a timeline considered for the first SMR in Estonia. But I want to emphasize that this is definitely something that needs to be pursued. However, licensing efficiencies can be enhanced greatly through maximum utilization of existing safety case and PSAR, as well as the corresponding safety assessment done by an experienced, independent, and transparent foreign regulator. Whatever the case is, the licensee will eventually have the prime responsibility for the safety of the plant, and therefore the license applicant will need to demonstrate intelligent customer capabilities. And they need to be competent enough to undertake their own safety assessment of all the licensing documents. And in the same way, if the Estonian regulator chooses to maximize the use of a safety assessment of a foreign regulator, they still must be competent to, and also they must undertake their own independent safety assessment. And this is in order, for example, to verify the completeness and adequacy of the foreign safety assessment, to ensure that the local or site-specific features have been appropriately addressed, and finally also to assess the license applicant's specific matters. All the safety assessments should be based on graded approach, and from the Estonian regulator's depth of safety assessment when it comes to technology, that should prioritize deviations from the standard design or reference plant, and also the safety significance of the items. And this study presents one possible approach, and there are other ones existing and other possibilities, and any details can be further discussed and adapted depending on the framework where the model would be utilized. However, utilization of a standard design, PSAR, and a foreign safety assessment, That is only possible if the regulatory basis and the safety standards in Estonia and the relevant foreign country are harmonized. And therefore, the Estonian legislation and regulations should set safety targets compatible with international practices, but they avoid setting detailed prescriptive requirements. And in practice, this would mean some kind of endorsement of regulatory requirements of the foreign country. Graded approach. The use of graded approach could also be recommended for the codes and standards in such a way that the higher safety classes, the codes and standards of the country of origin, could be used in them, whereas then the local codes and standards could be used in the lower safety classes. And this is especially considering the non-safety equipment and a long operating time, something that is seen beneficial. And what does this everything then mean? It means that there really needs to be cooperation between the Estonian and the foreign regulatory bodies, because significant human resources may be needed, and this might require government-to-government commitment. And finally, the suitability of the site envelope-based PSAR, and especially the availability of the PSAR and also other relevant licensing documentations that could be developed or would be maybe developed or owned by a foreign licensee as opposed to the reactor vendor, that must be ensured. And this is also applicable for the existing safety assessments. And with this quick run as an introduction to the safety study, I want to hand over the word to Helen.
Thank you very much, Nici. It's now my great pleasure to introduce you to Fermi Energy's Licensing Advisory Group. This group was established in the middle of last year to oversee the work of Fermi in the areas of nuclear regulation and licensing. Our experts are drawn from and have experience working in countries and with regulatory bodies likely to have particular significance for Fermi Energy's SMR deployment plans, as well as having important affiliations with entities such as the International Atomic Energy Agency and the Nuclear Energy Agency of the OECD. So Nici, if you could turn to the next slide. The members of our advisory group are Stephen Burns, the former chairman and commissioner and also general counsel of the United States Nuclear Regulatory Commission. And Steve is also the former head of the Legal Affairs Department at the Nuclear Energy Agency of the OECD. We also have Ian Grant, who is the former Deputy Director General of Operations and Director of Nuclear Safety of the Federal Authority for Nuclear Regulation in Abu Dhabi, UAE. And prior to his time in Abu Dhabi, Ian held various senior management positions with the Canadian Nuclear Safety Commission. We also have Juhani Hyvänen, who is the former Executive Vice President and Chief Nuclear Officer of Fennovoima in Finland. And prior to this, Juhani held specialist and management positions at the Finnish Radiation and Nuclear Safety Authority. And finally, we have Joseph Mizak, who is the former Director General of the Slovak Nuclear Regulatory Body, and also the former head of the Department of Nuclear Safety of the IAEA, and an expert regarding IAEA safety standards, WENRA safety reference levels, and the European utility requirements. Now, these few sentences certainly do not do justice to the impressive and extensive experience of this group of experts, and we've been really honoured to have them working with us. Now, the first task of the advisory group was to review and engage with us on the Fermi Fortum licensing study that Nici has just presented, and we greatly appreciated the inputs and guidance obtained from our experts. Separately, but relatedly, I'm happy to announce that the advisory group has developed and endorsed a set of SMR licensing principles, which will be made publicly available today. These principles recognise that successful deployment of SMRs in Estonia and more widely are significantly influenced by the applicable licensing process and regulatory basis. They encourage a proactive and constructive approach to addressing licensing and regulatory challenges, which should be embraced by all stakeholders. And they broadly concur with the high-level findings of the Fermi Fortum licensing study. So you can see a copy of the SMR licensing principles here, and as I mentioned, they will be made public today. So again, we'd like to thank our advisory group for the work that they have done with us to date, and we look forward to our ongoing collaboration. And with that, Maria, back to you.